Hi, and welcome to this presentation. My name is Mahmoud Al-Nasri. I'm a Pavement Design Manager with Tarmac. Today, in this presentation, we're going to discuss the new updated design DMRB, Design Manual for Roads and Bridges for the pavement. We will highlight the key changes, including some analysis and impacts on the industry. So 2020 witnessed the release of the new updated DMRB, Design Manual for Roads and Bridges for the pavement design section. And today we're gonna focus on the changes for three main documents used in the pavement design, which are CD224 Traffic Assessment, formerly known as HD2406, CD225 Design for New Pavement Foundation, formerly known as IAN 7306, and finally CD226 Design for New Pavement Construction, formerly known as HD2606. Typically, for a pavement design and to understand the background, the design process includes three steps. The first step is to calculate the traffic, which is now done using CD224. The second step goes alongside the first step is the design for pavement design foundations, which is CD225 covered this part. The outcome from the two designs goes into CD226, which is the pavement design, which covers the calculation of the total thickness required for the pavement. It should be mentioned the skid resistance and the surface cost requirement are part of the process. However, they are not included in this presentation, but available in CS228 and CD236 respectively. To start with, the CD224, the traffic assessment. The principle stays the same, which is calculating the magnitude of loadings over the design period for the road. The equation T, which is the design traffic, equal 365 times F, which is the annual average daily flow in one direction, times Y, the design period, times G, the growth factor, times W, the wear factor, and times P, the percentage of commercial vehicle in the heaviest loaded lane. So the equation stays the same. However, the details of the parameters calculation has slightly changed. To start with, the F, the annual average daily flow. Formerly, in the HD2406, the minimum percentage of OGV2 is other goods vehicle, class 2, was calculated or obtained from the figure based on the daily flow commercial vehicle per day. Now, in the new updated CD224, the requirements goes to minimum 70% of OGV2 from the overall traffic. This is to minimize the risk of underestimating the traffic, particularly for the heaviest type, which is OGV2, that has the highest impact on the pavement. Going on to the next factor, G, the growth factor. Previously, it was given in HD2406 as a table based on the design period. Similarly, is given in CD224 based on the design period, you get the growth factor. However, the number is changing. If you can notice, there is an increase in the growth factor for OGV1 plus PSV. OGV1 is other good vehicle type 1 plus PSV. PSV is public service vehicles by up to about 4%. For OGV2, other good vehicles type 2, there is a decrease down to 8%. This has been done based on the 2006 to 2016 Department for Transportation Traffic Forecast. On to the W. W is the wear factor. The wear factor is actually the factor used to convert the axle loading for each vehicle or each type of loading into a standard axle loading, known as 40 kilonewton for one single tire or 80 kilonewton for an axle loading. It is given previously in HD2406 either by category or by class, similarly given in CD224 as either by category or by class. In terms of changing the numbers, by class, it stays the same. There is no change in the number. However, by category, there is a significant change. Or to be particularly more particular, there is a significant increase. Again, this is to reduce the risk of traffic underestimation. Finally, P, which is the percentage of commercial vehicles in the heaviest lane. Previously in the HD2406, it was determined based on the number of the flow of the commercial vehicle per day given by the figure. Now it is calculated based on the flow and the number of lanes. So based on a calculation, you can get this number. Also, there is an inclusion of 4 or more lanes category for the calculation of the P percentage of the commercial vehicle in the heaviest loaded lane. Moving on to the next standard, which is CD225, the design for new pavement foundation. As we know, there are two types of foundation approach design. There is the restricted design approach and the performance design approach. The restricted design approach offers assurance of the performance for the foundation through the use of a limited palette of well-understood materials. There are different options, and you can see in the table. There is the first option, which is the single layer. Then we will cover later on the sub-base plus capping and sub-base class 3 plus capping. Also, as we know, there are different classes of the foundation, class 1 to 4, based on the surface modulus, class 1 being above 50 MPa, class 2 above 100 MPa, class 3 above 200, and then class 4 above 400. So for the option of single layer, the categories capping only class 1, sub-base only class 2, or sub-base only class 3, the same option has been taken forward from IN 7306 to CD225. However, for the sub-base only, which using class 2, material type 3, which is open graded, has been replaced by 807 type 4 asphalt arising. For the sub-base only class 3 option, there has been an inclusion of 3 different materials, which are 821 CBGM minimum C34, 822 CBGM minimum C34, and finally 840 soil cement minimum C34 or C810. This is in addition to the already available material in the IN 7306. Moving on, the second option for the design of the foundation is sub-base class 2 plus a capping. The IN 7306 only has one option, which is variable capping plus a sub-base. The CD225 has an additional option, which is constant capping plus sub-base class 2. This includes different material, which are capping 614 to 615 and 643, which are cement stabilized, lime stabilized, lime and cement stabilized soil. For the sub-base material, the new addition of 807, clause 807, type 4, asphalt arising has been added. The third option, sub-base class 3 and a capping, This is a new addition to CD225, which was not covered in IN 7306. It allows for variable capping or a constant capping plus subbase class 3. Capping could be for the variable capping plus subbase class 3. You have option for capping from 613 class 613. And for the subbase, you will have the normal class 3 in addition to CBGM, C34 or C82, 821, 822, and 840 as shown in the table. So anything in red is in addition to the already approved material for class 3. Moving on, the second approach for the design of the foundation, known as the performance design approach. The performance design approach gives flexibility to the designer in terms of the materials that can be used in the foundation. However, this is subject to achieving a surface modulus of value equal or higher than the values shown in the table on the presentation. The options are single layer, subbase class 2 plus capping, class 3 plus capping, or class 4 plus capping. The new update includes the changes in the values in the surface modulus in class 2 from being category for single layer from 150 to 120, and for class 3 for single layer reduced from 500 to 350, and for class 4 there has been an addition of 4000 MPa surface modulus material. For the other option, class 2 and a capping, the same applies for the CD225 from IN 73, except that the 150 now reduced to 120 MPa surface modulus. The addition is now the subbase class 3 and a capping. This is a new addition in CD225, and subbase plus capping, subbase class 4 and a capping also is a new addition to CD225. So in terms of determination of the thickness, previously in HD24 and in IN 7306, the determination of the thickness is based on either you have the CBR or the surface modulus MPa of the subgrade. Now, mainly here the CD225 focuses on the MPa, the surface modulus of the subgrade. There is an equation there that converts between the CBR and the MPa. However, now it is limited to values between 2 to 12% CBR to convert to MPa surface modulus. Overall and in general, the new CD225 requires equal or thinner foundation design thickness in comparison to IN 7306. Key changes in the design includes the first one, whenever improvement is applied where the CBR is less than 2.5% or 30 MPa. Previously, the IN 7306, even after the improvement applied, it restricts that the design CBR should be maximum 2.5%. However, CD225 allows this to go up to 5% or 50 MPa. Consequently, the foundation thicknesses will reduce. The second one, when you have the subgrade CBR less than 5% or the subgrade surface modulus of the surface modulus of the subgrade less than 50 MPa, there is a new requirement in CD225 that the foundation should consist of subbase and a capping, while this was not the case in IN 7306. Finally, no departure is required any longer for the use of the performance design approach under the CD225. This will encourage the designer to take more advantage of the existing material, providing more sustainability element for the design. Finally, the CD226, the design for new pavement, which was previously HD2606, is the document used to calculate the overall design thickness of the pavement. It provides different options, fully flexible, flexible composite, or rigid options. What are the additional new updates or new requirements? For design for new pavement, there is a requirement now to provide at least 3 alternative options. Also, the design thickness is now rounded to 5 mm rather than 10 mm previously. For the fully flexible and flexible composite options, DBM50, HDM50 are now referred to AC4060, and this is to align with the BS-EN standard. HRA50 and DBM125 materials are no longer available in CD226. For the rigid option, which is concrete, URC, unreinforced jointed concrete, and JRC, jointed reinforced concrete, are now only applicable for widening and reconstruction, and it cannot be used for new construction. Probably the most significant addition for this document, CD226, is the introduction of the RCC, roller compacted concrete. It has a requirement of 90 ml of either EME2 or HRA clause 9432 as a binder course. The new addition also includes the online widening, and for this option, at least 2 alternatives should be considered, whether it is fully flexible, flexible composite, or a rigid. 40-year design life is a requirement for an online widening. Last but not least, the new additional requirement for the pavement design verification. And this involves the production of a pavement design report that need to follow an alternative design checking procedure. Pavement design certificate should be approved by the designer. A certified pavement designer who has this qualification should only carry out this. And this new certified pavement engineer qualification can be obtained through the Institute of Asphalt Technology. Thank you very much and for listening. Thank you.